This is Lab 1 for Physics 2212. So our objectives were to identify the charges of the tape through our understanding of electric fields. The models that were used was the electric field equation, then also the electric force equation, and then Newton's second law, which calculated F net through adding F electric plus F grav. And then the discoveries were the charge needed to oppose gravity and allow the tape to repel up. And then our system was the top tape, and then the surroundings were the bottom tape and gravity. So then our initial conditions, the tape was 20 centimeters and mass a very, very small number of kilograms. And then the separation between the top and bottom tapes was, when repulsion was noted, was 2.5 centimeters, and the displacement due to the repulsion was 2 centimeters. So the coding in part 1 identifies the electric field on the top tape and identifies the electric force by the bottom tape and identifies the force of gravity on the top tape, treating the top tape and the bottom tape as single point charges. And then the findings were that the charge was equal to 9.41 nanocoulombs and the force of gravity is about 1.99 e to the negative 3 newtons. So then the coding in part 2 identifies the electric force and continues it over the points in the tape. So we've got multiple point charges. The electric force was found to be 1.34 e to the negative 4 newtons. And then our nanocoulombs for the electric force are on the screen right now, based on all of the line charges. And so potential sources of error was measuring the tape separation and displacement distances. Since I was doing it alone, it was very difficult to basically be able to not only take pictures of the actual experiment as it was going, but then also be able to measure the displacement and separation as well. And then also massing of the tape. I used an off-brand type of tape, so the information provided in the instructions might not have been right. So this could also affect the force of gravity that ended up being found. And then the measurement of the tape, I had to estimate the size because I kept getting the tape stuck on the ruler and then also getting it stuck on each other. So I kept having to re-get tape. So tons of errors could be very, very likely in this particular lab. And then the what if electrons are negatively charged and protons are positive charged? What if the signs of their charges were reversed, meaning if electrons were positive and protons were negative? What would change about your observations you made with your tapes and other charged objects? And since the concluded charge was positive, the tape's charge would be attributed to protons being aligned to face the negatively charged pen. However, if protons and electrons were to switch the sign of the charges, the electrons would be the ones facing towards the pen and the protons would be facing away. Otherwise, nothing would change. So like the charges wouldn't change. It would still be a positive charge facing towards the pen that has the negative charge that is causing the attraction towards the pen. And then the why. So why compare the estimated value of your charge you get when your experimental data to produce a point charge model to the value you got when you did a line charge model. The two computational values for Q will be different. Why are they different, and which value is more likely to be closer to the real value and why? The values are different because our squared changes over time depending on where you're looking at in the line charges. Our first model assumes that R will remain the same without that being the case. A value that is closer to the real value for the total charge would be the one with more points, since it is looking at the whole piece of tape, not just one specific location above the other tape. So basically you are looking at each individual point on the piece of tape, and that allows us to calculate the net charge over the course of the tape rather than just in one specific location. So thank you so much, and I will see you in the next lab.